Now let's take our next question, that is question number 16. As per this question, this belongs to section of electromagnetism from chapter electrostatics. Here, there is an electric dipole which is formed of two equal and opposite charges separated by a distance d. It is placed in a uniform electric field. Both the charges have mass m. Now, it was in equilibrium when it was slightly rotated from its equilibrium orientation by some angle, that is the small angle, and then its angular frequency omega is. We need to find omega here. Now, in this case, you must understand that in the case of equilibrium, it is at rest, that is torque acting is 0. But when you disturb it from the equilibrium, then the torque acting, that is the restoring torque acting on it, would be minus Pe sine theta. Since it has been disturbed slightly, so theta would be very small, right? And when theta is small, then you can write tau would be equal to minus Pe into theta, and this tau would be equal to I into alpha. From here, you can also understand that alpha can be written as d2 theta by dt square. That would be equal to minus Pe by I into theta. This represents the standard condition of d2 theta dt square, that is equals to minus omega square theta. Comparing these two equations, this is equation 1 and this is equation 2, we would get omega is equals to under root P into E by I. Now, what is the dipole moment? Simply it is Q into D into electric field. What is I? So for moment of inertia, let's write I for now. These are the two masses M and M having charges Q and minus Q. They are separated by a distance of D. So from here to here it is D by 2. This dipole will perform oscillation about the axis which is passing through its center. So moment of inertia, if you want to find, would be I is equals to M d by 2 whole square plus M d by 2 whole square. Solving this, you will get I as md square by 2, right? So you have moment of inertia as well now. Just you have to put down this value here. You will get omega as under root Q d E divided by M d square by 2. On solving, you will get 2 QE by MD. This would be the omega in this case. Let's see which is the best suited option. Among the 4 given options, option 1 would be the right answer. Now let's move on to our next question. Now the question you see here belongs to section of mechanics from the chapter rotational motion. A rectangular solid box of length 0.3 meter is held horizontally with one of its sides on the edge of a platform which is 5 meter height. When released, it slips off the table in a very short time of 0.01 second, remaining essential horizontally. The angle by which it would rotate when it hits the ground will be. So it's a pretty tricky question. First of all, let's see what are the things given here is the 5 meters. So what is the time taken by this rod to fall on the ground under the conditions of free fall? So that would be capital T is equals to under root 2h by g. That would be 1 second, right? Now, when it is about to fall, so currently there is some torque acting on this point. So it will be the weight which is acting downwards, and it is about to rotate about this point, which will form a pivot about the axis which is passing out from the board. Then the torque acting would be, let's start with the solution. Torque acting would be mg, length of the rod L by 2, as it is acting on the center point, that is half of the length, and this should be equal to I alpha. I here would be ml square by 3, as the axis is passing from the edge of that rod, right? When you put down this value, what you will get is mg L by 2, that is equals to m L square by 3 into alpha. This and this will be cancelled, m and n will be cancelled. So alpha would be 3g by 2l. You have the alpha with you. Now this happened for a very small duration, that is equals to 0.01 seconds. So in that duration there was some angular velocity which has been gained by this rod. So the angular velocity in that small duration will be simply given by omega equals to alpha tau. So that is equals to 3g by 2l into 0.01. So now let's put down the values. This is 10, this is 2, this is 0.3 into 0.01. This is omega, which will be half radian per second. And with this angular speed, the angular distance or the angle which it will travel in this time period of 1 second would be simply omega t, that is theta would be omega t, that is equals to half radian, right? Let's see which is the best suited option here among the 4 options. So among these 4, answer number 4 is the right option, right? Now let's move on to next question, that is question number 18.